Welcome, everyone. Yes, I know it's a long title, but network is really important for Microsoft Teams. So let me introduce myself a little bit. I'm Johan Delimon. I live in Belgium. I'm a long-running MVP. Also did the master training. I am also a trainer. You can find all the details on this slide. So before we dive in, we have to explain a little bit how networks used to be set up in the past, right? Because we all have legacy, and Teams, of course, uses the network like it is deployed at customers today. So I'm just setting the scene now, and it's really simple, right? If there's issues with Teams, we just blame it on the network. But that's maybe not the best approach, because we have to work with the network in order to make it more optimized to work with Teams. So let us go back to where it all started. Like for all the enterprises, we had just a local network, and this pre-internet, right? We didn't have any internet services at this point. We just wanted to have computers to talk to each other inside the corporate network, right? So what happened? We had clients, we had some computers, and they were able to connect, right? Everything was fine. Security was great because there's no external threats. And this is how it was set up. But of course, when internet came to be, then suddenly we wanted to take resources from the internet and access them from the internal side. So what started to happen was that proxy servers and firewalls came into the picture here, and then accessing those resources on the internet usually involved accessing a proxy and then a firewall to get through the resources that you wanted, right? But of course, this has also another effect, and of course, it's good for security, control, compliance. We all want to know how this all works. And then if you look at trust, like only the green boundaries are trusted, right? Inside the corporate network, we have the trust. And all of the internet is considered like unsecure, and we are not trusting that. So what happens when we want to extend our internet or our Corp organization or Corp network to the internet, because people started to work from home or traveling or other things, we want to have access to our internal resources. So essentially firewall, but that firewall is going to block all of those connections. So it was usually the solution, okay, let's implement a VPN solution so that our users can actually go through the VPN to connect to our internal resources. While that's a good idea, it doesn't really mean that that's going to be optimized. So essentially now we're trusting still not the internet. Of course, we're trusting the client connected from the internet going over the VPN connection. But of course, this client, when it wants to access resources on the internet, it has to go also through the VPN, right? So this is the red line here, which doesn't really optimize connecting to internet. So of course, now we are in a situation where all of the internal resources are going to move to the cloud or have already been moved to the cloud. So, but we're in many situations still stuck with the legacy networks. So what happens here is that internal users need to connect to the internet to get to their resources, for example, Teams. Potentially people from remote sites need to connect over one connection and then break out locally to those resources. And the same goes for people connecting through VPN, right? They still go through proxy and firewall to connect to those resources. So I'm just saying here, what is a trusted network? It's still not the cloud. So this is obviously something that we need to solve. So there are many problems here that we need to solve step by step. Like, first of all, proxy servers, not really good idea. Or if you have to use proxy servers, then we have to do some tweaking. Of course, firewalls are a big pain. It has been for Skype for Business. It is still for Teams. So we have to make sure that firewalls work smoothly with or have the right configuration. VPNs are always an issue because they still hairpin through the corporate network, remote offices, and essentially Office 365 is not trusted destination, and that's what we need to make it. So let's first of all tackle proxy servers. So proxy servers are in the mix here. So we hope they don't interfere with the traffic when we're connected to the internet and to the cloud resources. Now, if you do that, it will probably still work, but it's better to remove the proxy from this configuration altogether, because essentially we have already moved all your precious resources to the cloud, but we don't allow you to connect to them in a secure way. This is kind of counterproductivity. So essentially we want to remove the proxy from the mix here. And removing the proxy doesn't mean you have to remove it entirely. No, maybe we're only removing it from the connections to the cloud that we need to connect to. So essentially, let's remove the proxy, but then we still have the firewall to worry about. So potentially the firewall is still blocking. So either removing the proxy or making sure we're going to bypass it, and then firewalls we'll have to handle in the next topic. So how do we actually do this? So either we remove it altogether, right? That's the easiest way, or we use a proxy.pack file, and it has all the necessary URLs so that we say, okay, all of those URLs, we're going to bypass them for the proxy. So you can do this in GPO as well, but proxy pack is probably the most used. So essentially, we want to have direct connections to the internet and to the Office 365 URLs without any proxy interfering and looking at the packets and then potentially mingling those packets so that the connection is not going to be great. So firewalls may still be in the mix, and then URLs change all the time. So that's also an important one, and probably a difficult one because you have to take into account that you have to do some things. Now, luckily, Microsoft has good resources. So there are two URLs here where we have all of the Office 365 URLs and IP addresses. And then the second one is a web service which actually which allows you to hook up to and get the right information from. And that will always be up to date, right? This information will be, if you check it daily, it will update with the right addresses and URLs. Now, this is how it looks like. So all of the URLs and IP addresses, and you see there's a whole bunch, right? I don't have enough space on my screen here to show it all, but there's different categories and there's lots of IP addresses, there's lots of URLs, and we'll have a take a closer look at it. And then we'll also look at the web service, which essentially spins out all of the IP addresses, all of the URLs, and this is not the final list, right? So lots of things to worry about. So if you want to configure the proxy server the right way, luckily there is a pack file generator, and essentially you can download this pack file, which has all of the required configuration in place, or you can use that to copy and paste into your existing pack file. So it's kind of like a PowerShell script. You say get pack file and you say what do you want to connect to. So there's documentation how to do this. And this is essentially how it looks like. So you get back a file that has, for example, if the match host, we have a host that matches these URLs, then we're going to go directly without the proxy server. So, and then you can use this pack file, and there's a long list, right? Because I have 3 dots here. So there's a long list of URLs. So that's kind of important. So now that we tackled the proxy server, Now we are going to look at the firewalls. So we tackled the proxy server. We're fine there. Now we do want to connect through the firewall and make sure that all the connections from the internal network to our cloud resources are going to be working and working in the right way, right? So essentially the same thing happens here. We need to allow all the Office 365 IPs and allow all the required ports. It's simply said, it's a long list of ports and IP addresses. So let's have a closer look at that. Yeah, and I added express route because if for one reason or another this firewall cannot be changed and there is no other way, then potentially we can look at express route, which essentially bridges the cloud resources with your internal network next to the firewall, right? The firewall won't interfere here, but usually most customers don't really need those express route connections. So when we look at the Office 365 endpoints, which means the IP addresses, the URLs, we have three categories, which means one of them is going to be optimized. So we require this to be optimized in the firewall. We have the allow and the default. So obviously we do want to have all the configurations in the firewall, but if we have to do only one, then it's going to be the optimized. And let's hope we can also do the required one because there's bandwidth and connection count is a little bit smaller than the first required one because this is really sensitive and it's going to be audio and video traffic. And then of course there's the not required section, but still if you can do it, it's always better to do. So there's a long table because this is again the URLs and IP addresses table, but here you see everything in red. You kind of have to do, right? And it's not that bad, right? We have like three range of addresses, and we have 4 ports that go with that. So these ports are the audio video ports for Teams and Skype for Business, and they are really, really highly critical, I would say. If a firewall would block those ports, it's not going to work. If a firewall would interfere with traffic going to these ports, we would also probably get some congestion and bad quality for audio and video. So the best thing to do is if you can only do one thing in the firewall, you have to do the optimize required. 3 IP address ranges and then 4 firewall ports. Of course, if we can do more, we would also like to do the green lines, and then you see there's a little bit more configuration required here. And then the default one in yellow, I would say also try to do it. It will benefit you. So firewalls and proxy servers, we've handled them right now. So let's look at the VPNs. So people connected from home, working in a VPN solution, trying to connect to cloud resources should go in a much more optimized way and access those cloud resources, not going over the VPN, but directly to the cloud resource. This is also important because VPNs add latency, of course, delay, potentially packet loss, and potentially packet reordering to your audio and video streams, which is not going to be great. And of course, potentially it still has to go to a firewall or a VPN concentrator somewhere in your organization, maybe not the closest to your data center where your data lives. So it's always better to connect directly to your resources and then try to alleviate the VPN connection. So one tricky thing that you have to do if you want to do this is you need to configure split VPN tunneling. It's become easier talking to network teams to do this, but in the past this was really, really a hard thing to do because it has the idea that the security is going to be less, and that this is not something an organization wants to do. But of course, more and more organizations understand that now the endpoint is also going to be secured, and then you have the right connections to the cloud. So essentially, we still have to work with the Office 365 IPs and URLs, and then try to alleviate them from the VPN tunnel. So again, we have the URLs and the web service here. Mind that the web service for a proxy, firewall, and VPN solution, some of those solutions actually connect to the web service to make sure that everything is going to be updated automatically, so that you don't really have to watch every couple of weeks if something has changed. So that's, of course, something you need to check with your solutions, but there are out there that take this web service into account. So essentially, this is where we want to go to. Like now, suddenly the cloud resources are going to be green. Like, okay, we're trusting them now because we allow all of the connections to go the proper way and have the fastest possible connection that we can have and the most optimized one. So suddenly Office 365 is going to be a trusted location, just as your data that's currently living there. Now, this doesn't mean that there cannot be any other problems, because potentially there's a round trip delay or an internet breakout that may help things as well. So let's look at that. And of course, this is maybe for the more larger organizations, because if you have just one location, potentially this is not an issue. But what Microsoft Teams has is transport relays. And those transport relays are deployed all over the globe and are deployed as close as possible to the users, which means there are much more transport relays than we have data centers where Teams lives. And this is important, right? Because you want to connect to a transport relay as close as possible from your corporate network to those relays. If I connect from my corporate network to a relay that's going to be far away, I'm going to put some extra delay, right? So we want to connect as close as possible and as fast as possible to a transport relay. And this transport relay will obviously connect really fast to the cloud resources. So essentially, this is what we're going to do through the firewall, and we connect to the transport relay directly. But we potentially have remote sites, and I know it's changing now as well, but usually all the internet connections, well, in the past were central breakouts. So that means we had just our headquarters, we had an internet connection, and then all of the remote sites just use that same connection. And we go over the one, which means that if this remote site is at the other side of the world, then it's probably better that we connect to another transport relay, right? So this means that potentially we will need to set up an internet connection from that remote site, right? This will optimize those remote site connections. So from our headquarters, we already have the connection. And then from our remote site, we just want to connect to the transport relay as soon as possible. And that will go to our cloud resource over the Microsoft network with the lowest amount of delay that you can have and the best quality there is. So just saying local breakouts in every location, that's going to be key, or that's probably going to be the best idea if you want to have the best performance. What's also important is that your ISP, so someone that you are using to connect to internet, has a direct peering connection with Microsoft, because then there's just one hop between your network and Microsoft network, which is really fast. And then express routing corner case scenarios, but I'm not talking about that. So important here is, how do we make those decisions, and how do we say, okay, we absolutely need a local breakout at all of the locations, yes or no? So essentially, there are values that we need to take into account, and those are all documented at Microsoft. So it means from the edge of our network, like our corporate network, the edge, like where we actually jump onto the internet, the one-way latency should be under 30 milliseconds, 60 milliseconds round trip. Of course, we don't really want to have packet loss, but on the internet, you know that can happen. And then jitter needs to be under 15 milliseconds. So this is for the actual network boundary of our network. But then if you look at clients, so the actual client sitting on the network, somewhere in the network, it needs to have 50 milliseconds. One-way round trip is 100 milliseconds. Of course, the less packet loss that we have is more interesting, and then jitter needs to be under 30 milliseconds. Jitter actually means that packets may arrive in the wrong order, which adds delay, right? Because we have to reorder those packets and wait until the right packet gets in to replay the audio and video streams. So jitter can pose many issues if you have high jitter values. So essentially looking at this, so the network edge, so going from the edge of our network to the transport relay, so we know round trip is 60 milliseconds, and then client machine is going to be 100 milliseconds round trip. So, and hopefully this is the same for the other sites, because if we go through a central breakout and that delay is going to be longer than 100 milliseconds, then yeah, we know this is going to pose a problem. Now, how do we test this? How do we actually go ahead and say like, okay, we know those values? Well, you have to use a tool. And Microsoft has released a Microsoft Teams network assessment tool that you can install on your client machines. It's going to be it's a command line tool, but of course you can script around it to do automatic things. But the thing is that you want to install it on a laptop or a computer and put it on the edge of your network and in the client segment of your network, and then run all of those tests. So if you just run it, it will check connectivity in general. Like it won't perform many tests. It will just say, okay, I have some relays where I want to connect to, and is it available? So we're connecting to this port, looking at QoS, is this port available, right? And it will give you a response. Just saying this is a basic test. Another test is the infra connectivity test. It will do many things, and it will spin out a result and say, okay, for the configs, we can connect to all of the configs and all the URLs are working. So we're good here. And then there's the quality check as well, which essentially will spin out real audio conversations and check with the transport relays what is the audio quality of this conversation. So you see here the latency is 18, 19 milliseconds. Jitter is 18, 19 milliseconds. So we know this is under 100, this is under 30. We have packet loss rate of 0. So this kind of looks like a good call, right? So, but of course, we have to replicate this, because just having one good call doesn't mean all your calls are going to be good. So you can configure this tool to run multiple times, and then you can import this into Excel and then make a nice graph of it. So let me quickly go to this tool. So I installed it here. So let's just run this. And I can obviously run all the tests because sometimes it takes a while. So again, it's checking here. And it says checks is successful for all relays. Now, I know this is going to take a while. And of course, we just have 40 minutes for the session. So I'll continue here. So what do you need to do? Like, of course, you have to take into account the local network. We have to take into account Wi-Fi connections. We have to take into account VPN, remote locations. So you have to validate everything. And the best thing to do is run this for a week, because that's how real network assessments are going to happen, and then get all your results. Then potentially you have to remediate some things. So I did this for a customer once, and then, for example, Wi-Fi inside, we have average, minimum, and maximum. Everything looks good, except from time to time there were spikes. So the run trip was higher, and then, well, it's still not too high, but the jitter was too high. Of course, Wi-Fi networks and jitter, that really can happen. But of course, this table doesn't say everything. We want to plot it into a history graph, and then you see, okay, it only happened 1 or 2 times, so that's probably fine. But then looking at the Wi-Fi, you see, okay, we want jitter. I think this is jitter. Yeah, this is jitter. So 30 milliseconds. We kind of have like probably 10 times a spike. Is this going to be an issue? Well, maybe it is, maybe it's not. Wi-Fi is not easy to fix, but at least you know, like, okay, this can happen. Now there's one other tool, and it's the Office 365 network connectivity test, which actually runs tests through the browser. Now the downside of this, or the good thing is it's visual, and the downside is you can only run it once, and then you have to manually run it again, and it takes a while. But it kind of looks like this. You run this from your machine, and then we'll say, okay, we are currently in the best section here, between 80 and 100%. This is where we're located, and these are all the data centers that we connect to. And then we'll say a little bit more information here, which exchange from door, for example, are you using, which are the best exchange from doors. And then you can actually, if you say, it will download a specific file, and then you can actually run this download specific file to run advanced tests. And then it will go a step further, and we'll do additional tests. Right, so then it's progressing those tests, and then it says, okay, we have more information here. It includes DNS, for example. How long does DNS take? Do we have a proxy server? It was not identified, no VPN detected. And then it looks at the Exchange pieces, the SharePoint online pieces, and then, of course, the Teams pieces. So, and here we see media connectivity issues. It doesn't find any issues. We don't have packet loss. We have a latency under 15 or 50 milliseconds and jitter 14 milliseconds. So we can conclude, yeah, it's fine. Of course, this is just a single test, which, yeah, won't always explain the entire network performance. And then you can do all the connectivity paths, and then you can look at the network path. You see, I'm actually using Telenet, which is a local IT provider in Belgium. So last section is going to talk about QoS and internal firewalls, because they can also put some issues on your connections and your audio and video streams. So we can have internal clients, right? And they may be in different sites. Of course, if you're in the same site and there's no proxy server, you will connect. If there's a proxy server, a firewall, for example, that firewall may block connection for those 2 clients. I've seen that at customers, but the way how Teams works, it will still find a way, right? Because the transport relays are going to be used in this case and hairpin the connection. This may not be too bad, right? Because the transport relay is probably going to be the same one, and it's still going to be a decent performance because it's going to be close to your network. But of course, if you look at the other side where we have a remote side and we have some firewalls, yeah, you see that the transport relays will be different, probably in that case, and then we'll hairpin through the Microsoft network, which, to be honest, some clients already have asked me, like, I want to connect this way because the Microsoft network is very performant, and we don't really trust our internal network. I'm just saying, normally you should allow through your internal network and make sure that your firewalls allow these connections. So if we allow them, everything is fine. Now, when we want to do this, we have to take into account what are the audio ports that audio video ports, application sharing, file transferring that our clients are going to use, right? These are the ports, 50,000 until 50,019 for audio, and there are 20 ports. So they are the same for Skype for Business and Teams, which makes sense, right? And this is going to be used for peer-to-peer communication. And of course, if your client connects to the Teams service in the cloud, it will also use these ports locally on the client. So if you want to change them, you can, but these are the standard ports. If you want to change them for any reason, you can, right? You can do that through the Teams Admin Center in the meeting settings. Then if you want to have good quality over your internal network, then you should apply QoS, because then you're going to prioritize audio video traffic, for example, in your internal network. And then you have to use those ports, TCP and UDP. And for audio, you will use the SCP value of 46, which is expedited forwarding. And for video, you would use 34, which is assured forwarding. So, of course, your network team will know how to handle this, right? So you just need to talk to them and make sure that this is going to work. So if you want to do this, you'll have to use GPOs to configure this or manual configuration on the client. And the port ranges are adjustable. And most likely you're going to use the Teams exe application to use in those GPOs, because those GPOs say you probably only want a Teams client and not your entire client. I would say your entire computer, because potentially other applications can also use those ports. So you want to limit this to Teams.exe. So one last thing I want to show you here is that more and more customers are moving to SD-WAN. Many customers are already on SD-WAN, but of course this may also put some limitations on connections to internet. But now Microsoft released informed network routing, which is a solution for SD-WAN. And currently there's one vendor that actually applies this and make sure that all of the connections, including going over SD-WAN, are going to be optimized for Microsoft 365. So just saying, if you have Cisco SD-WAN solution, you can actually go a step further and make sure that your SD-WAN is going to be optimized. I'm sure many other vendors will follow shortly, but for now, it's just Cisco. So let's look at a summary, how we're going to fix our network. So first of all, proxy exceptions, right? We don't want to have a proxy server in the mix. We want to go direct. Of course, firewalls, we need to allow the proper ports and direct connections without blocking them, all of the ports that we need, certainly for audio and video. For VPN, we want a split tunnel VPN and then have access directly from the client machine directly to the cloud resources, because we're already on the internet. Let's just connect directly. Then we have to take into account round trip delays, local internet connections. So make sure that the values that we need for a good audio video performance, that we can actually meet them. in every location. And then lastly, we'll have to look at, do we need to optimize the internal network with quality of service, and maybe also tweak the internal firewalls. So all of those things, it's not something a Teams administrator will do, but we'll have to work with the network teams in order to make this happen, right? So that's the key conclusion here. We have to work together with the networking team, make sure that this is all going to work. So I want to thank you for attending, and if you have any questions, the floor is open.
Thank you, Johan. I think there was just one question. How will QoS help over public internet?
Well, it will not help over public internet, right? Because QoS is for the internal network, but there are still a lot of companies that have internal networks, and of course, connections to remote sites inside the internal network that probably need to be optimized, because Teams is sharing network traffic with all of the other applications running on your network, and you want to make sure that the audio video streams are going to be put on top of your network priority and always have the best performance. So it's not for the internet, because there's no QoS on the internet. If you want to optimize internet, make sure that you have a local internet connection in all of your sites so that you're directly connecting to a transport relay as fast as possible, and then you should be good to go.